Hi folks, we're going to take a look at page 564, number 5b. So they want us to find the points on this relation where the tangent is horizontal. So in other words, we need to determine where dy dx is equal to 0. Okay, so since this is a function defined implicitly, likely a relation defined implicitly, and I definitely can't solve for y explicitly, I'm going to use implicit differentiation. So the idea here is to take the derivative of both sides of the equation. Okay, so derivative of 5x squared with respect to x, nice and easy, that's just 5 times 2x, so that's 10x. Okay, minus 6 times the derivative of xy. Well, this is a product of two functions, so I'm going to have to use the product rule. So derivative of x is 1 times the second function is y, plus the first function x times the derivative of the second function, and that's just the derivative of y with respect to x, and I'll represent that by y prime, save myself a little bit of writing. Okay, but you have to keep in mind that these derivatives are all with respect to x. Okay, and finally we have 5 times the derivative of y squared. So again, this is the derivative with respect to x, so I need to use the chain rule when finding the derivative of y squared. First find the derivative of the outside function. Derivative of y squared is just 2y, and I multiply that by the derivative of the inside function, which is just my y, so y prime. All right, and now I've got derivative 16, that's just a constant, which is equal to 0. Okay, so now we've differentiated both sides, and we notice that I have dy dx in two of my expressions here. So the goal is to group together everything with a y prime on the left, and then I'm going to bring everything else to the right. So first I'm going to simplify the left-hand side here. So we've got 10x, so that's going to be minus 6y minus 6x y prime. This is going to be plus 10y y prime equal to 0. So again, I'm going to group together everything with y prime, and I'm going to factor out the y prime. So here I'm left with y prime, and I'll put the positive one first. So I've got 10y, and here I have minus 6x. And then everything that didn't have y prime will be brought to the other side. So minus 6y becomes plus 6y, and 10x becomes minus 10x. And then finally, I can solve for y prime, and that'll give me my derivative. So 6y minus 10x over 10y minus 6x. Okay, so part A of this question asked you to determine the derivative of at 1, negative 1. So I would just take y equals negative 1, x equals 1, input it into this expression, and that'll give you my derivative. Okay, but now what I want to find is where this is equal to 0. So I want my derivative to be equal to 0. I'll actually simplify this a bit. I'm going to factor out a 2 from both numerator and denominator, and that'll reduce. So if I factor out a 2 from the numerator, I'm just left with 3y minus 5x, and here that's going to be just 5y minus 3x. All right, and in order for this fraction to be equal to 0, I need the numerator to be equal to 0. So that means 3y minus 5x has to be equal to 0. So 3y has to be equal to 5x, and y has to be equal to 5/3 x. Okay, and what I see here is that I haven't actually found any specific values for either x or y. All right, what I did find though is a relationship between x and y. Now there's infinitely many pairs that satisfy this relationship, it's just a line, but I'm only interested in those which are on my relation. So this is where I'm now going to take this relationship between x and y and input it into my original equation to solve for specific values. Okay, so wherever I see a y, I'm just going to replace it by 5/3 x. Okay, so we've got 5x squared minus 6x times y, which is 5/3 x. Okay, plus 5 times y squared, so 5/3 x all squared, and that's equal to 16. And now I see that I have an equation solely in x, so I can solve this. So I'm just got to take the time, be careful with my algebra here. So 5x squared, here the 3 and the 6 will reduce, so I'm just left with minus 10x squared. So that's good, at least they're like terms. And here plus 5 times, well, let's square this here. So it's going to be 25 over 9x squared. And I see yet another like term, so that makes life a lot easier. Okay, so here we have 5 minus 10, so we have negative 5x squared. And here we're going to be left with plus 125 over 9x squared. Okay, so let's keep simplifying here. So let's put this over 9. So it's going to be negative 45 over 9, which is equal to 5x squared plus 125 over 9x squared. So here, this is just a bunch of arithmetic. So negative 45 plus 125 is going to be 80 over 9x squared equals 16. Okay, and so x squared is equal to 16 times 9 over 80. This cancels, it's just equal to 5 there. So I have x squared equals 9 over 5, so x is going to be equal to plus or minus the square root of 9 over 5. Okay, and we can actually simplify that a little here. Plus or minus square root of 9 is 3, so 3 over root 5. All right, so these are the x values for which my derivative is going to be equal to 0. But since they're looking for the points, I need to now input that into my relationship between x and y to find the y value. So 5/3 x. Okay, so one option is for y to be 5/3 times positive 3 over root 5. Okay, so I'm just left with 5 over root 5, or y is equal to 5/3 times negative 3 over root 5, which is almost the same thing, just negative 5 over root 5. Now here, if you think of this, 5 over root 5 is like 5 to the 1 over 5 to the half. It's just going to be 5 to the half, so it's actually just going to be root 5. We can actually simplify that. So our final answer here at the bottom of the page, okay, our 2 points are going to be, first one, 3 over root 5, and the y value is root 5, or negative 3 over root 5, and the y value is negative root 5. And there's our answer. Okay, so just to recap here, I want to determine where the slope of the tangent to this curve is horizontal, or sorry, where the tangent is horizontal. So in other words, where the derivative is equal to 0. So step 1 was to determine the derivative, and I needed to do that by implicit differentiation. And here I realized I had a fraction, so in order for that to be equal to 0, the numerator had to be equal to 0. But what that provided me was just a relationship between x and y. It didn't give me a direct answer, so I had to input that relationship back into the original equation to determine my value for x and then my value for y. Okay, that's it for this one.